Okay guys, I'm going to give you some hints for the post-assessment for current electricity. I'm starting here in the reference table just to show you what equations we need to focus on. We've got Ohm's law over there. We've got equations for figuring out power, and there's 3 different equations. We've got an equation for figuring out electrical energy, and on this side we're going to be using that equation for figuring out the resistance when resistors are in series. This one when resistors are in parallel, and I think this one over here that the current's the same in a series circuit, the current doesn't change. And then this one we're going to use as well, where you get the total voltage. You've got to add up the voltages of all the sources if they're connected in series. So keep your reference table handy. Let's get going here. Right, number 1. A circuit contains a voltage source, 4 resistors connected in series. If the voltage is decreased by 1/2, what will happen to the current flowing through the circuit? So Ohm's law, V equals IR. Whatever happens to voltage is going to happen to current. If the voltage is going down, the current is going to go down. And however much the voltage goes down, well, that's how much the current is going to go down, because they are directly related, directly proportional. Question 2. The circuits shown below are made using a battery, a lamp, and a rod. One circuit has a copper rod, the other one has a rod made of glass. Copper, we know, is a good conductor. Glass is a non-conductor or an insulator. I think this question is pretty obvious. Question 3. A scientist used a material which allowed electrons to flow easily from atom to atom. What can be assumed about the material the scientists used? Again, this question is, I can't believe this is an exam question, but anyway, you guys know that insulators don't allow current to flow through them and conductors do, so you should be able to do that one. Number 4, an electrical appliance can work with a 12-volt battery. It can also work by being plugged into a wall socket. What type of voltage conversion is needed between the wall socket and the appliance circuitry when the appliance is plugged into the wall socket? So the wall in your home is 120 volts AC, and we want this appliance to run on 12 volts. And so there's a transformer, which is basically like your cell phone charger, but this appliance will have a different one because your cell phone doesn't work on 12 volts. That's going to change 120 volts AC into 12 volts and 12 volts DC. Okay. Number 5. A 60-watt light bulb in a 120-volt lamp is left on for 3,600 seconds. What amount of energy does the light bulb consume? In your reference table, I showed you this equation. E, electrical energy, equals power multiplied by time. We have the power, we have the time. Number 6. A 3 ohm resistor is connected to a 6-volt source. What is the power rating of the circuit when the 6-volt power source is changed to 12 volts? So on your reference table, you've got this equation, P equals VI, and P equals I squared times R, but P also equals V squared over R. And since we have a 12-volt source that's being used, that's your voltage, remember to square it, and we have the resistance, we can figure this out. We don't need to worry about the 6-volt source because they're saying it's being plugged into a 12-volt source. Number 7. The diagram below represents a DC circuit. The current flowing through the 8 ohm resistor is 1 ampere. What is the current flowing through the 6 ohm resistor? Well, this is a series circuit. In series circuits, the current doesn't split up. The current is the same at all points in this circuit. So we know the current through the 8 ohm resistor is 1 ampere. I think the answer should be pretty obvious there. Number 8. The diagram below shows 2 9-volt batteries connected in series across a 6 ohm resistor. When you connect batteries in series like this, and this equation is in your reference table, we are simply going to add those 2 voltages up. So our total voltage in the circuit is actually 18 volts. And now we're simply going to use Ohm's law. And Ohm's law is really a key for this section. You use this equation more than any other one. V equals IR. Ohm's law is also written as R equals V over I. And that's how it originally was written when that relationship was figured out. Anyway, V equals IR. We've got our V, and we have our R, which is 6 ohms. So solving for I should be pretty simple. I is current. Number 9, the last one. Below are 2 diagrams of different circuits. Circuit 1, circuit 2. Circuit 1, you guys can see there's a series circuit. Circuit 2 is a parallel circuit. And to figure out the total resistance in a series circuit, because this is what the question's asking for, we're simply going to add those resistors up. So REQ, or total R, equals R1 plus R2. When we add those up, we're going to get 12, we're going to get 6. We add those up, we get 18. So what we're going to do is we're going to eliminate some answers here. Circuit 1 has an overall resistance of 0.25. We can eliminate that because we know it's 18. In B, it says circuit 1 has an overall resistance of 4. Well, we can eliminate that one. C and D both tell us that the resistance is going to be 18. So we know the circuit resistance of 1 is 18. We just need to figure out what circuit 2's resistance is. They've given us 2 answers. And both answers are reasonable, because the resistance of a parallel circuit is lower than the lowest resistor in that parallel connection. So what you guys are going to do is you're going to use this equation. 1 over REQ equals 1 over R1 plus 1 over R2. And you're just going to substitute. So it's going to be 1 over 12 plus 1 over 6. Find the lowest common denominator of those two. Add those fractions together. And then you're going to flip it around, because we don't want 1 over R, we want R. So flip this side around to find out R, flip your fraction around, do the math, and you should be able to get the answer. Right, let me know if you've got any more questions.